living things in the baseball bat.
All right. Okay, so here we go. If you go to table 16.2, I'm going to teach you what KSP is in like 30 seconds. KSP is the same as KP or KC. The bigger it is, the more products there are, and the smaller it is, the less products, very good, or the more reactants. Okay, so if you look above table 16.2, those three equations, that's what KSP is basically all about. If you take a solid ionic substance and try to dissolve it in water, does it dissolve well or does it not dissolve very well? And the KSP, again, is products, or the K is products over reactants, but if you look at those three equations, you have MgF2 solid, Ag2CO3 solid, Ca3PO4 2 solid. Solids don't go in equilibrium expressions. They're not in there because there's so much of it. Remember, we talked about that. So it's just the concentration of the ions. So those three are examples of KSP equations. So how do you write a KSP equation? It's just the ions multiplied together, raised to their coefficient. Now, if you look at the table, the numbers are kind of all over the place, but in general, what do you notice?
Really small.
Yeah, really small numbers, okay? So if you look at bismuth sulfide, it's like the fifth one down on the left there, or fourth one? Fourth, fifth? Negative 72. That is so small, it's like, why even measure that? Now, if you look at lead 2 chloride, all the way at the bottom. Stay with me, stay with me. Lead 2 chloride on the bottom. 2.4 times 10 to negative 4. That's significantly larger than 1.6 times 10 to negative 72. What do you think that means? Just think here for a second. Think to yourself. All this KSP is showing is a solid dissolving in water. That's all it's showing. A dissociation in water. So if you have a really, really, really small KSP or a much bigger KSP in relation to the really small one, what does that mean? So don't answer. Think. So I'm just going to put one in our notes here. Which one do I have? I have. You can copy this down before I call on somebody. Keep that open though. Keep the book open. Okay, so KSP equation is just the concentration of the two ions that are in solution. Sorry, I forgot AQ. Multiplied by each other. And if there's a 2 or a 3, then you raise it, just like we've learned. There's nothing new here. It's actually a little bit easier because we don't have any reactants to deal with. It's just all product. It's not really a product, but the product of the dissolvents. All right, so does anybody have an idea here? The number, what does that tell us?
The smaller the KSP, the better it is. Because
Say that again.
the smaller the number.
So we're talking bismuth sulfide, 1.6 times 10 to negative 72. Bless you. Okay.
The worse results because there's smaller concentrations.
So there's smaller. So the smaller the concentrations here, the better this dissolves.
No.
No? No. So the larger the concentration here, the better this dissolves.
Yeah.
Okay.
No.
I had it straight in my head and it didn't come out right.
Now I like what you're saying. He's saying you're right. So don't get confused anymore. The larger these concentrations are, the better this dissolves. Does that make sense to everybody?
Yeah.
And if this dissolves very well, then these concentrations will be really high. Well, how does that affect this number? Larger. Right. So you're right, but I think you said the first part backwards. The larger this number, the more soluble the salt is. We're going to write that down, but I'm going to first write this number before I forget. The KSP is 1.1 times 10 to the negative 10. 1.1 times 10 to the negative 10. We're going to use that in an example here. But here's what I want you to get out of the table there. We're going to talk about a couple of them. But this is just the theme. If you remember this kind of overruling theme here, it makes all these problems easier. And the larger the KSP, the more soluble the salt is. That's because the KSP is directly dependent upon the concentration of the ions. So if the concentration of the ions are big numbers and you multiply them together, then you're going to get a pretty big number for KSP. However, like Earl said, they're all pretty small numbers. So on that table, they're all small numbers, but some are significantly larger than others. All right. The reason that this chart, they all have small numbers, these types of problems we're going to do are with salt that aren't very soluble, because if they're like salt, for example, NaCl, 100% dissociates, you don't really have it. It's harder to have like an equilibrium scenario because all of it is dissociated. But that's where these numbers come from. So that's two things I wanted to just teach you right off the bat. How to write the expression, which you already know. Products over reactants, but we don't put reactants in. So it's just products times products, which are these two. So that's how you set up a KSP equation. And now this. The bigger that number, the more soluble it is, the smaller that number. Do you remember that question on the midterm? It's the one I gave you the answer to. It said, the question said, you probably just wrote the answer down and moved on, but the question said, using the above KSP values, predict which salt is more soluble or something. Yeah, I don't know, it was like Al, was it aluminum plus 3 was the answer? Yeah. But, so all you needed to do on that question, it's easy now, all you need to know is this one little thing, is that the smaller that number, the less soluble it is. The bigger the number, the more soluble. So that's important to remember. Okay. All right. So if we use this example, and then there's another one I have here, aluminum hydroxide. If we take AlOH3 solid, and we put it in water, dissociate. So you obviously need to be real good at dissociating ions here. I don't really teach that. I expect you to be able to do that. Okay, so Al plus 3 and 3 OH minus. The KSP, what would KSP be for this one? Is this thing directly in your way?
Yeah, no, it's just a really good picture.
Are you taking notes from the notes on the screen there?
Sure.
Anyways, what's the KSP? Concentration of, I'll put it up here. KSP, concentration of Al plus 3 times concentration of OH minus cubed. So we're going to do ice tables. Inside this would actually be 3x cubed. So just keep that in mind. That's where that math, it's not that hard, but it comes in handy to remember how to do the old exponents and whatnot. Okay. All right, so anyways, the value of this is 1.8 times 10 to the negative 33. So which one is more soluble in water? Barium sulfate or aluminum hydroxide? Barium sulfate's not even close. It's like 23 powers of 10 bigger. All right, so this is way more soluble. You guys remember the formula for the yellow solid? I always make it every year. I mix those two clear solute colorless and it turns yellow. PBI2. PBI2. Find that on this chart. What's the KSP of PBI2? Right. So what does that really mean? It means some of it actually does dissolve. So we say in Regents Chem, if you see a color change, you see a white precipitate or a yellow or whatever, we say it's insoluble. Now you're basically everything is soluble to some degree. So there's really no pure insoluble. So. I'm gonna start saying that. What? Kids throw the ball away. Yo, that's Regents Chem.
Yeah, that's what I heard is Regents Chem.
All right, I'm recording this. I can't. I gotta go in. I'm just kidding. All right. So back to this. They're never gonna see it, and you're not gonna share it.
No.
All right. Okay.
Yeah, only 'cause they're calling.
All right, back to this here. All right. So again, we're going to be using Q and K. So Q and KSP. So Q versus KSP. Same concept. If Q is less than K, what does that mean? Which way are we shifting? If Q is less than K, we have to make more products, right? And if Q is greater than K, right. So now, what does that have to do with this? Well, KSP has to do with solutions. So if Q is less than KSP, we have three types of solutions, Earl. What are they? I don't know what he just said. There's three types of solutions. I'll give you a hint. Put just a little bit of solute, put just the right amount, or put too much.
Super saturated, saturated, and
Unsaturated, right. So unsaturated, saturated, super saturated. So now, what do you think that has to do with Q? If Q is less than K, are we unsaturated, saturated, or super saturated? Justin's saying unsaturated.
Okay.
Do you agree?
No, there's more. Yeah, no, it's super saturated. No.
Remember, if it's Q is less than K, that means that's initially you don't have enough to be at equilibrium yet. You don't have enough what? Products, right?
Yeah.
I feel like you should just tell us since my brain
I
hurts.
think that it's C is unsaturated. Let's go with it.
Should give us multiple choice questions.
Remember, look at here. Look, here's the deal. So if we had, go back to this one. We'll just use this as an example. So if you have this, right? So initially, you have less ions than at equilibrium. So we have to shift this way if Q is less than K. We know that. What does that mean? Does that mean
There's more room for dissolving.
there's more room for dissolving? Yes, that's a good way to put it, Ben.
Yeah.
So what type of solution do we have?
Unsaturated.
Unsaturated. So Justin was right.
You know,
It's called a distribution.
Who said why? Marcy? Okay. So in this solution, this beaker, wherever it is dissolved, you have a certain number of ions. But those ions are smaller in number than they should be at equilibrium. So the only way to reach equilibrium is to dissolve more of this into the solution. So if you're dissolving more, that means there's space for more, so that means you're not saturated yet. You're unsaturated. That's my next question. That's when Q equals K. Q equals KSP is when you're saturated. That's when there is no more room for dissolving. All the ions have saturated the solution. So when Q equals K, this is balanced and you can't dissolve anymore. So I really like the way Ben said that. If you have room to dissolve more, that's unsaturated. So you're going this way. If you can shift this way, that means that there's space, that you didn't reach saturation yet. And if these two are equal, then you're doing this and this at the same time. No one's changing, so you're saturated. Am I helping?
Yes.
Sort of, Marcy?
I mean, yes.
Well, don't just say that. Maybe as we proceed. Yeah. Okay. What about the last one's easy, obviously. If Q is bigger than K, supersaturated. Supersaturated. So if you have too much, so actually you know this. If you have a beaker of water and you add way too much solute and you just keep stirring, what's never going to happen? Not all of it's going to dissolve. It's just going to settle to the bottom. That's what that means. So you have too much here. We're going this way. It's going to start to precipitate. If you have too much dissolving, too much solute you're trying to dissolve, it'll start precipitating. So if you have if this is a saturated solution, all right, it's kind of hard to just visualize this, but if this is saturated and I add more solute to it, it's never going to dissolve. It's going to sink to the bottom. That's what that means. So you have too much, and it'll precipitate. Give me an example. We did it in lab. You can eat it. Rock candy. Yeah. We overloaded it with a higher temperature, so we overloaded dissolved ions. Once it cooled down, it could no longer handle the extra solute, so it precipitated. We were doing this. Okay. All right. So this is equilibrium. Make sure we understand that. This is equilibrium. So remember, in Regents Chem, I always tell them, you got to memorize. Saturated means equilibrium. I always say memorize it, memorize it. It's really hard to explain why. This is why. It's because the Q equals KSP. If you try and teach that in Regents, you know, brain matter comes out of ears. All right. What's the KSP for AgCl on that table? 1.6 times 10 to the negative what? 10. Yeah, that's for AgCl. So if you wanted a unsaturated solution of silver chloride, what does your final concentration of Ag plus have to be? If you want an unsaturated solution of AgCl, what does your final concentration of Ag plus have to be? Less than that number. Very good, Ben. That's what KSP tells you. It tells you that's the max. What if you add more than that number? Then it's going to precipitate. You're not going to dissolve it all. What if you add exactly that much? It should all dissolve and you'll be saturated. You add even one more crystal, it'll precipitate. So that's what KSP tells us is kind of the balance. Less than that, we're dissolving everybody. More than that, precipitating right at that number, that's saturated. Okay. Oh. Solubility. Dang it. Ran out of time. Wait a second. You were supposed to have homework.
No.
Well, you didn't learn enough
I
yet.
don't think I understand. So we got the pre-lab, we got corrections.
You have a pre-lab. Yes.
Yeah. What are
Those two whole questions are only.
There's like 2 questions that'll take you 5 minutes.